In most data analysis scenarios, we have to work with data, and the first step is that we make a model for it. So you have data and we create a model for it. Now it is not uncommon when we do not have a unique model for the data, but instead we have a whole lot of models for the same data set, and we are at a loss as to which one is the best one among them. One example could be where you are trying to fit a polynomial regression and you are not clear as to what should be the optimum degree. So you are comparing between polynomial models of different degrees. As yet another example, we might consider this, that we are trying to model it like this, that y is a linear regression on e to the power x. Now we can also work with logarithm of y and fit a linear regression of logarithm of y. Both these models may be appealing for the same data sets, yet these two models are not exactly the same, and you need to choose which one is the better one. And on a different note, you could have a homoscedastic model, something like a Gauss-Markov setup model, and you believe that homoscedasticity is not a good assumption. You want to compare it with a heteroscedastic model. It could be that you are more or less convinced that a heteroscedastic model is what you need, but there are lots of different heteroscedastic model possibles, and you have to compare between them. In all these cases, you have different types of models, and you want to say which one fits my data set well. And this video addresses certain techniques to do that. Now, right at the outset, let us get rid of two commonly held mistaken notions. Number one, what we are trying to do is really comparing between models, comparing among models. This is not the same as, for example, a test of hypothesis. In case of test of hypothesis, you are given some particular model which you know is true, like x1 to xn, IID, normal mu sigma square. There is no question about this model being true. You are trying to answer questions that go deeper into the values of mu and sigma square, like you are trying to test that mu is equal to 0 or not. The fact that it has a normal distribution is beyond all question. But what we are trying to do is we are comparing between two models. We are not yet certain whether this model is the correct model or that model is the correct model. It is quite possible that none of these two models is the correct model. We want to know which one fits the better. It is possible that the best fit that we get among these models is not yet a good fit. So it is more an exploratory type of thing than a formal, rigorous test of hypothesis setup. Now the second thing is that what we are trying to compare are models and not trying to compare various estimation methods. Like we are not comparing whether I should take mean or whether I should work with median. That's a different type of question. In this case, we are comparing between two models, which one is a good fit and which one is a bad fit.